explanation on the uncovered syllabus in the adsorption chapter, especially for the B.Sc second sem students. In case of adsorption, I have covered some basic concept of the adsorption and also the definition of adsorption and causes for the adsorption, and based on the bond between the adsorbate and adsorbent, there are two classes of adsorption. One is physical adsorption and chemical adsorption. So in the regular class, I already covered the definition of what is physical adsorption and what is chemical adsorption, or a physisorption or a chemisorption. Now let us go for discussion about the differences between the physical adsorption and chemical adsorption. Look at this, the PPT that is present on the screen. I given the representation, diagram representation. In case of physical adsorption, the adsorbate molecule held on the surface of adsorbent with a weak van der Waals force of attraction, whereas in case of chemical adsorption, the adsorbate molecules held on the surface of adsorb by strong bond, that is a chemical bond. See, this is a chemical bond observed on the surface of it. So based on that, now let us go for the difference of physical and chemical adsorption. The first thing is there's a nature of bonding. The adsorbate molecules held on the adsorbent by weak van der Waals force of attraction, whereas in case of chemical adsorption, the adsorbate held by strong chemical bonds. And the second difference is the enthalpy of adsorption. The enthalpy of adsorption means the amount of enthalpy or heat content liberated when the adsorbate molecule held on the surface of adsorbent. That means adsorption being an exothermic reaction. So based on that, now if the substance undergoes a physical adsorption, the amount of heat liberated is found to be low. There is a low enthalpy of adsorption varying from 20 to 40 kJ per mole. Whereas in case of the chemical adsorption, since the adsorbate held on the surface of adsorbent is strong, therefore the high enthalpy of adsorption varying from 80 to 240 kilojoules per mole. Now the third point is reversibility. Means the adsorbate held on the adsorbent can be reversed or not. In case of physical adsorption, the adsorbate molecule can be easily reversed because of weak van der Waals force of attraction. Whereas in case of chemical adsorption, the adsorbate molecule held on the adsorbent is not possible to reverse it. That means we cannot deadsorb it. Then nature, it is not specific in nature and it is highly specific in nature. Means the same surface of the adsorbent can have any number of adsorbed molecule on the surface. That means either you can adsorb the CO2 on the surface of the charcoal, or you can adsorb NSC on the surface of charcoal. Like this, the different type of substance can adsorb on this. So it's not specific for the particular type of adsorbate molecule. But whereas in case of a chemical adsorption, the one surface meant for only one type of adsorbate molecule. So it cannot take other molecules on the surface. For example, if you take the tungsten, it can adsorb only hydrogen. If you take this platinum, nickel, it can adsorb only hydrogen, whereas nickel cannot adsorb CO2 gas or ammonia gas. That is what is highly specific in nature. Now, when you observe this, fifth is structure. Means the layers on the surface of this physical adsorption, chemical adsorption. Here now it forms a multi-layer. So we can expect a number of layers, first layer, second layer, third layer. Number of layers can expected on the surface of the physical adsorption molecule. Whereas in case of the chemical adsorption, the surface covered only with a thickness, unimolecular thickness. Once the one molecule of this molecule is adsorbed on the surface of the adsorbent, and we cannot expect one more layer of this adsorbate to sit on the surface. That is what the specification concerned to this nature structure. Now this the sixth point is the energy of activation. The energy of activation is low, and whereas the energy of activation is high. See, energy of activation is already discussed in case of chemical kinetics. is the minimum energy the reaction molecule has to possess to undergo chemical reaction. Similarly, in this case, that every adsorbate molecule has possess a minimum amount of energy to get adsorbed on the surface of adsorbent. Whenever the molecule get adsorbed on the surface of adsorbent, if it is a physical adsorption, then the low energy factor is enough to get adsorbed on the surface of this adsorbent. Whereas in case of a chemical adsorption, the adsorbate molecule get more amount of that high energy of energy activation. That means they need more amount of energy to get adsorbed on the surface of adsorbent. Therefore, so the physical adsorption is having a low energy of activation, whereas a chemical adsorption has a high energy of activation. Now, what is the effect of pressure? See, if it increases by increase the pressure, and pressure has no effect after the formation of unimolecular. That means the effect of pressure, if you take a gas, it is to be adsorbed on the surface of a solid. When you go on increase the pressure of the gas, the more and more molecule approaches towards the adsorbent, and now it is go as you increase the pressure, that adsorption goes on increases. That's because of the increases now the more and more layers are expected to form on the surface of the sun. Whereas in case of the chemical adsorption, so once this the unimolecular thick layer form the surface of this whatever the pressure increase, no, there is no increase in the further adsorption of the molecule on the surface of adsorbent. Therefore, it is only unimolecular, whereas a multimolecular or more than one layer can expected for this. And whereas the effect of temperature, as I told you, that means it is being exothermic reaction. So increase in temperature or decrease in temperature always causes the change in the rate of adsorption or amount of adsorption. So since that it has a low energy of activation, the adsorbed molecule can readily adsorb on the surface of adsorbent at low temperature. That low temperature favors the adsorption. Whereas the energy of activation for the adsorb is very high. Therefore, in increase the temperature, the energy of activation molecules goes up increases, and the more and more molecule get activated. Now, at high temperature is required, so it favors the adsorption of the adsorbent on the surface of adsorbent. So these are the important the differences between the physical adsorption and chemical adsorption. Now let us move on to next concept. That is, we have the different type of adsorption. Adsorption of a solution by solid adsorbent. Again, adsorption of a gases by the solid. Like these are the different type of adsorption. Among those, we shall have the concentration on adsorption of the solution by solid adsorbent. Means we prepare a solution. Into the solution, you add adsorbent. You can see either a solute molecule or a solid molecule can adsorb in the surface of adsorbent. Now, the adsorption of the solution by solid depends on the certain factors. This adsorption by solid from the solution depends upon the following factors. One is the nature of adsorbent, and second is the surface area of the adsorbent, and third the nature of the solvent and solute, and fourth is the effect of temperature, and fifth is effect of concentration. Now let us go for the study of the effect of concentration first, then I'll come to the next one. So as you know, the effect of concentration, the variation of extent of adsorption with the concentration is given by Freundlich's equation, which for the adsorption from the solution is written in the form of xy x upon y is equal to k into c raised to 1 upon n. So x upon m is equal to k into c raised to 1 upon n. That is the adsorption Freundlich equation that tells about the extent of the amount of adsorption of the substance on the surface of adsorbent depends on the concentration. That's what you can say. Based on the extent of adsorption, either a solute or solvent on the surface of adsorbent depends on the concentration. Okay. Now, based on that, now let me take. We have the two important types of adsorption. One is a positive adsorption and a negative adsorption. Now let us consider a solution. When you say the solution, which consists of a two component, a solute and solvent. Okay. After having the solution, if you drop a activated wood charcoal into it, now it depends on the nature of solution. Means whether the concentrated solution or a dilute solution, the adsorption by the adsorbent may have the different types. So based on that, now we have the one is a